Hey everybody, this is Russo and we're going to be talking about volume. Now, when I think of volume, I usually think of the volume on my stereo or my phone, but that's not the kind of volume we're talking about today. The kind of volume we're talking about is the size of an object or how much space it takes up. And here we have two elephants. Both are legitimate elephants. They have legs, ears, trunk, elephant things. But these elephants don't have the same volume. I want you to think to yourself, which elephant takes up the most volume? If you chose the actual elephant, that'd be correct. This takes up more size or space than this little guy over here. So both same objects, completely different volume. Over here we have a trickier one. Here we have two objects. Same question. Which one has the most volume? Now, you may be thinking to yourself, oh, that, hot air balloon, that's pretty big. But man, this is a A1 Abrams battle tank. This thing is huge. It's a monster. It weighs a lot. It's a big thing. So clearly it weighs about 52 tons standard. So it probably has the most volume. If that's what you were thinking, you were a little wrong. Because it's not about weight or how much stuff is in it. It's just about size. And you could drive about 8 or 9 tanks into this balloon. Now, the balloon couldn't fly, but that's another lecture. So scientists need to ask the question, how big is something? What is the volume of an object? This guy right here has a pretty big volume, although it looks like his body's been twisted backwards for some reason. I'm not too sure why. There are two ways to find out an object's volume. The first one uses math. The second one uses water. We're going to talk about math first, and we're going to talk about water in a separate video. This should look familiar from past days in science. Here we have an object. We have the object's height, width, and depth. When we take the object's height, width, and depth, we multiply them all together, we get the object's volume. Here's an example. Here we have a length, and another length, and a third length. One is the object's height, one is its depth, one is its width. See if you can figure out which one is which. I'll give you a moment. Okay, I hope you figured it out by now. 5 centimeters. This right here, is this the height, the depth, or the width? Hopefully you chose height. Over here, we have this 4 centimeter bar. This 4 centimeter bar is the height, depth, or width. Well, if you chose the depth, you chose right. And that can be the tricky one sometimes. This blue line over here is kind of a left to right line. And that should tell us that it is the object's width. In order to calculate the volume, we're going to multiply those three things together. Here we have 5 meters and 3 meters and 2 meters. And really what we're trying to do is figure out how many of these blocks fit into an object. So we're going to use the same thing we've done before. The volume is the length times the width times the depth. We have discovered that this top to bottom one right here, that's going to be the height. Left to right is going to be the width. And the 2 meters is going to be the depth. So we've got 3 meters by 2 meters by 5 meters. And if I were to do that in my head, I would do, let's see, 2 times 3 is 6. So 6 times 5 would be 30. I would say this is 30 cubic meters. Yep, it's 30 cubic meters. The reason I said cubic is we not only multiplied the 5 times the 3 times the 2, but we multiplied the meters times the meters times the meters. And that would be meters cubed, or m to the third. So let's recap. Volume is size. It's how much space something takes up. Big thing, large volume. Small thing, small volume. The volume is the length times the width times the depth. And the units are always going to be cubed units. That's all. So far, so good.